Welcome to the deep dive.
Hmm.
This is where we take the materials you're curious about, could be articles, lectures, anything really.
Uh-huh.
And we dive in and pull out the key insights for you. The idea is to help you get informed without getting, totally overloaded.
Yeah, cut through the noise a bit.
Exactly. So today we're digging into a lecture transcript somebody sent over. It's focused on generative AI.
And some pretty significant progress that's happening, like, right now.
Right. It's pitched as introductory, but honestly, it points to some really big shifts.
Definitely.
And we know you listening have all sorts of backgrounds. Some of you might be deep in the tech, others just, fascinated by what's new.
So we'll aim to make it make sense for everyone.
Yeah. Our goal is accessible, but also hopefully pretty illuminating. This lecture highlights, we've pulled out two main insights we really want to explore.
Yeah, exactly. And like you said, it's not just small tweaks the lecturer is talking about. It's pretty fundamental changes in what AI can do and just how fast it's all moving.
Mm.
So we'll start with this really striking compression. Like how much less time and fewer resources these things need now.
Right.
And then we'll get into how it's happening. This idea that deep learning models are learning to see patterns, kind of hierarchies, all on their own, automatically.
Okay, sounds good. Let's jump into that first one then. This radical compression of time and resources.
Yeah.
To really get it, the lecture gives this great before and after. So, picture this. Just 5 years back, maybe 2019,
Around then, yeah.
making, say, a 2-minute video of someone talking, and it wasn't even a real person's recording being mimicked perfectly, more like a generated avatar speaking.
Right, a synthetic output.
That was a massive job. The lecture mentioned needing weeks of data collection.
Like 2 hours of pro audio, 50 hours of HD video.
At about 15 grand, $15,000 in compute power.
Yeah, huge resources.
And even then, after all that effort, the output could only perform a pre-written script, no spontaneity.
Very static.
So you contrast that huge custom project with today. It's almost, the lecture implies it's becoming something you could almost do on your phone.
It's a staggering difference. It's not just making it faster, it fundamentally shifts who can even do this stuff.
Exactly. And that contrast is where it gets really interesting, right? What did the lecturer show was possible now?
Well, apparently they demonstrated creating a pretty convincing voice clone almost instantly.
Instantly. From how much audio?
Just a few minutes of someone talking, like maybe 3 minutes.
Wow. Okay.
And here's the kicker. That cloned voice to then hold a natural, unscripted conversation.
So not just reading lines, but actually interacting dynamically.
Exactly. The lecturer framed it as moving from a massive static undertaking, that old way, to an immediate, flexible one.
That really does make you pause, doesn't it?
It's mind-blowing, yeah.
Because the transcript really hammers this point. This isn't just like incremental improvement. A realistic voice created on the fly that can have a normal conversation.
Yeah.
That was, maybe sci-fi territory just a few years back for most people.
Absolutely. And that speed of progress, how quickly these things went from lab projects to, potentially usable tools.
And how smoothly they integrate, like the voice cloning and the conversation part working together instantly.
Right. That seamless integration for dynamic use is key. It's not just that the tech exists in pieces.
It's the speed, the accessibility.
And the cost dropping through the floor, presumably. That's the fundamental shift.
Yeah. It sort of democratizes it, doesn't it? Opens it up for way more uses, way more people.
For sure. And the lecturer actually suggested, trying out one of the current AI voice tools yourself.
Ah, right. To actually experience it.
Exactly. To really feel how much things have changed.
Yeah.
It makes it less abstract.
Definitely takes it from theory to practice. Okay, that's a really powerful first insight. So let's move to the second one you mentioned. This idea of deep learning models learning a hierarchy of features automatically.
Yeah, and this is kind of the engine behind a lot of those advancements we were just talking about.
Okay, how should we think about that? The lecture used an analogy, right?
It did. Think about how we humans recognize faces. You don't just instantly see face.
Right. My brain sort of breaks it down.
Seems like it.
Yeah.
Maybe you first perceive simple things, like lines or edges.
Okay.
Then maybe how those lines form basic shapes. Circles, ovals, triangles for eyes or a nose.
Features.
Exactly. Features.
Yeah.
And then your brain puts those features together in the right arrangement to go, that's a face. Or even, that's your face.
Right. There's a kind of layering from simple to complex.
Precisely. A hierarchy. Now, traditionally, if you wanted a computer to do that,
You'd have to tell it every single step.
you got it. You, the programmer, would have to manually define the rules. Look for edges here, then look for 2 dark circles above a triangular shape there. Very explicit.
Very painstaking, I imagine.
And brittle. What if the lighting changes? Or the angle? Your rules might break.
Okay, so that's the old way. What's the deep learning breakthrough here?
So the breakthrough, as the lecture explains it, is that you don't program the rules. Instead, you just show the AI tons and tons of examples.
Like thousands or millions of pictures of faces.
Exactly. And by processing all those examples, the deep learning model starts to figure out that hierarchy on its own.
So it learns that edges are important first, then shapes, then features.
Kind of, yeah. It automatically discovers that these layers of abstraction edges, shapes, features, whole objects are useful ways to represent the data in order to make sense of it.
And the key is that automatic discovery. Nobody explicitly programs those stages.
That's the crucial part. The AI finds the relevant patterns and the hierarchy itself.
That seems really powerful.
It is, because the AI isn't limited by what features we think are important or how we think things should be broken down.
It might find patterns we wouldn't even notice.
Absolutely. It can find much more complex and subtle patterns in the data, making it way more robust and adaptable than the old rule-based systems. It's processing complex stuff in a much more, well, efficient and scalable way.
Almost more like how our brains work, maybe, in terms of learning from experience.
That's one way to think about it, yeah. It's learning representations of the world that work without us dictating every detail.
Okay, I think I'm getting a clearer picture now, and you can see how this connects back to the first insight, right?
Definitely.
This ability for the AI to automatically learn the important features, these hierarchies, that must be a big reason why the progress has been so fast.
Exactly. If the AI gets better at learning the underlying structure of things like speech or images,
Then it can probably achieve complex tasks like that voice cloning or conversation.
using less data, less computing time, fewer explicit instructions, the learning itself becomes more efficient.
Which fuels that rapid acceleration and makes things more accessible, needing fewer resources.
Precisely. It's a feedback loop, really. Better learning methods enable more complex applications, which pushes the learning methods further. These two insights are definitely linked.
Okay, so let's try and wrap this up a bit. In this deep dive, looking at that lecture transcript, we've really focused on two main things. First, just the sheer speed and accessibility. How generative AI tasks that were huge, expensive projects just years ago are becoming, well, almost immediate.
That dramatic compression of time and resources, yeah.
And second, we looked under the hood a bit at how this is happening. This fundamental shift in deep learning where models learn hierarchies of features automatically from data.
Discovering the patterns themselves rather than being explicitly programmed with them.
And it's important to remember, as the lecture kind of implies, these aren't just, technical footnotes.
Not at all. These are pretty fundamental changes.
Changes with potentially huge implications for, well, how we interact with tech, with information, probably in ways we haven't even thought of yet.
The pace itself is something to really mull over. Where does it go next?
Absolutely. Which actually leads perfectly into a final thought, maybe something for you to ponder after listening. Given this incredible speed up, this trend of complex tasks becoming almost instantaneous and widely accessible, what else might be next?
Oh, okay.
What other things that seem really difficult or time-consuming for us now might suddenly become easy, or at least much easier thanks to AI continuing on this path? What new possibilities open up then?
That's a great question to leave things on. What's the next impossible thing that becomes possible?